16 women working in this building developed breast cancer. Most were young. None had a family history of the disease. And many of them sat around this desk. The possibility of this being chance is literally 1 in a million. All the usual suspects were interrogated: radiation, pollutants, chemical contamination. But no environmental trigger was found. The entire site was evacuated in December 2006. The cause remains a mystery. One controversial theory is that the cancer was caused by a virus, perhaps even a mouse virus. It's not as bizarre an idea as you might think. 1 in 5 cancers are caused by infections. And new evidence is emerging that there may be more. That viruses and bacteria may be triggering some of the biggest killers of our time.
I feel confident that when all the information is known, that we will find that more than half of human cancer is caused by infection, and I suspect that it'll probably go as high as 90–95%.
As horrifying as it may sound, finding a hidden trigger, such as a virus, is not bad news. Quite the opposite. It's a cause for hope. Finding a cure for cancer is the holy grail of medical science, and it's the dream of many a doctor. But finding a cause of cancer offers the chance to stop it before cancer's epic journey even begins. When breast cancer struck the ABC studios right on his doorstep in Brisbane, pathologist Dr. Glenn Francis was presented with a rare opportunity. This unique group of women could hold clues to a disease that kills 500,000 people every year.
There we go. There's tea, coffee, food.
Glenn decided to reopen the case.
There's no doubt that this cancer cluster is one of the most extraordinary clusters anywhere in Australia and probably even in the world. The odds for this occurring by chance are incredible. It's extraordinary. The question we have, though, is what caused it?
There was a period of time over about 3 years where there was a rapid succession of women. I think there was about 7 in 3 years. It became very distressing, very stressful, and really hard on everyone because there was this sense of who's going to be next. When I was diagnosed, my whole world just fell apart. One day I was a normal, healthy 35-year-old, with 2 beautiful children, a job I loved, everything going for me. And the next day I was being told that, I probably wouldn't live to see my children grow up. For months after I was diagnosed, I would wake up in the morning and the first thing I'd think of was, oh my God, I've got cancer. How did this happen?
We had a 6-fold increase in risk of breast cancer, which, according to conventional statistics, was highly significant.
Professor Bruce Armstrong led the initial investigation into the ABC site.
We have not found a satisfactory explanation for the increase in risk. So that leaves us then really with either a mystery explanation, something to which we don't have an answer, or that this was simply a chance occurrence. We can never rule out that possibility. That is always a possible explanation for a cluster of cancers when no obvious environmental factor can be identified.
But there was one location his team had not explored, inside the women's tumours. Breast cancer is not one disease, it's multiple diseases found in breast tissue. And less than 10% of breast cancer is hereditary. For the other 90%, we know the risk factors, but not the cause.
As researchers, we can't do a thing without you. We need your participation, we need your tissue in this case to actually...
Glenn and his team will delve into the tumours, hunting for viruses.
So feel free to ask questions.
It's a provocative idea.
Clarify anything.
Whether or not viruses are important in causing breast cancer remains uncertain and somewhat of a vexed question, with some quite strong views on either side of the argument.
The point is not to say no to any one idea. We don't know what causes breast cancer, and breast cancer is still one of the biggest killers of women across the world. So we have to remain open to any possibilities.
And Glenn is not alone. Around the world, there are other researchers who believe that following the trail of infections may transform the future of cancer. One in 3 of us will get some type of cancer at some point in our lives. In the moment of diagnosis, the common cry is often, "Why me?" In London, leading cancer researcher Professor Mel Greaves has spent decades investigating why cancer strikes and how a virus can be involved.
I think it's interesting that there's a prevailing idea for hundreds of years about cause of cancer, the expectation that there might be a singular cause of cancer. I think the psychology of this is very interesting. I think what it reflects is a natural, understandable, but I'm afraid erroneous human desire to pin the blame on something. There must be a cause, there must be an external villain, there must be somebody to blame for this. But it's a too simplistic view. Cancer simply isn't like that.
To understand the role of a virus, it helps to understand how cancer starts. In part, it's a type of cancer lottery. Nearly every cell in our body replicates and eventually dies. The body signals cells to die when their time is up or if their DNA is damaged. This regulated cell suicide is normal. Cancer is not an alien invader. It's a single one of our own cells gone terribly wrong. Something corrupts its DNA. It no longer listens to the body's signals and, in effect, refuses to die. It becomes immortal, and it replicates, creating an army of mutant clones.
Every one of us develops small tumours, most of which never see the light of day. Fortunately, very few of those mutant clones develop into cancer.
For the most part, these mutant clones are wiped out by the body's defense systems.
There are restraints within the body that can prevent this process. And on the whole, they work. If they did not, we'd all be riddled with cancer from a very young age.
But time is on the clone's side. They can lie low for years, for decades, like sleeper cells waiting for the right combination of DNA hits. With each hit, they can mutate again and again, until one day, the clones have accumulated enough mutations to cross tissue boundaries and spread throughout the body. This is metastasis, and it's often deadly.
Starting from a single mutant cell, you can finish up with 1 million or 1 billion cells, but that begs the question, of course, of what causes the mutation, and that's been the $1 million question all along.
Time has come in America when the same kind of concentrated effort that split the atom and took man to the moon should be turned toward conquering this dread disease.
In the 1970s, as part of Nixon's war on cancer, millions of dollars were spent hunting viral causes.
I will also ask
A few were found, but overall, the results were disappointing. the big news that did emerge was the discovery of cancer-causing genes. And so, swept up in breathtaking advances in DNA research, the world turned to genetics for answers.
Well, since the discovery of DNA, everybody's been fascinated with genetic causes of disease. And we know that genes do cause certain diseases. But I think when we actually look at what we now know about the causes of cancer, I think that we've been underestimating the role of infections in causing cancer. I think that part of the story has been neglected.
In the US, evolutionary biologist Paul Ewald argues that viruses play a critical role and that it's time to look again.
I think it's a terribly important part because it looks like, for many of these cancers, it's infections that starts the whole process.
One cancer in particular has caused a rethink: cervical cancer. Over 150 years ago, the French coined a curious phrase, cancer à deux. It described the simultaneous occurrence of cancer in both the female cervix and the male penis, usually in a married couple. The cause was hinted at. Married women with philandering husbands were 10 times more likely to contract the disease. Nuns were in the clear. Sex had to be the link. In Germany in the 1970s, Professor Harald Zerhausen put the pieces of the puzzle together. There's a virus that causes genital warts, called HPV, the human papillomavirus. He suspected it might cause cervical cancer. But his idea was scorned by the medical fraternity.
This was received not only with skepticism, but from some of the participants with a certain degree of hostility even.
It was a difficult hypothesis to test. He went searching in the patient's tumours for signs of the virus, but it was hard to isolate, and even harder to extract.
The progress was very slow, and particularly in the 1970s, when we had great difficulties to purify the virus, we desperately needed it in order to prove our hypothesis. At that time, I was sometimes quite frustrated, I must say.
He didn't give up. After 10 painstaking years, his team finally isolated 2 types of the virus, HPV-16 and HPV-18.
So with these 2 viruses on hand, we had approximately 70% of the cervical cancer biopsies positive, and that changed the whole picture. And we distributed the samples all over the world, got it quickly confirmed.
HPV-16 and 18 were confirmed as carcinogens, capable of turning healthy cells into cancer cells.
I mean, from that moment on, the evidence became increasingly tight that it must be causal. And also the doubts in the scientific community, of course, persisted for quite a while.
In 2008, Harald Zerhausen won the Nobel Prize for proving that cervical cancer is caused by the human papillomavirus. It had taken him more than 30 years. Today we know there are over 100 strains of HPV, and they are involved in a range of cancers. And we know they spread via sex. The link was telling, after all. And with the certainty that a virus was to blame, came hope. If they could stop the virus, they could stop the cancer. Vanuatu, the so-called happiest place on earth. But behind the stunning vistas lies a terrible reality. Here, 1 in 10 women will develop cervical cancer. Mari Galeb is 45. She is dying of cervical cancer. She has chosen to leave her home to be near the water. Her family visit her.
2 years ago, we've been to the hospital, and the doctor said that it's got a cancer. And the doctor says that there's no treatment for her in the hospital, so we just come back home. It's losing the weight, going down, and when the pain comes low, we can't control it. So we must rush up to the hospital for the doctor to give her an injection.
I just only need a tablet or to release the pain, because when the pain comes, it's so difficult for me.
And when moms get sick, it's very painful to me. Yeah, it's very hard.
But now, a quiet revolution is underway. Working with colleagues around the world, Professor Ian Fraser and his Australian team developed a vaccine to stop HPV infection. It took 15 years, but the result was the world's first vaccine specifically designed to prevent a cancer.
Worldwide cervical cancer kills about 500,000 women every year. And since it's an infectious disease, effectively, what that really says is this is an epidemic of infection. Now, if any other infection were killing 500,000 women worldwide every single year, there would be an outcry about doing something about it.
Today, over 20 million women have been vaccinated across the Western world. But for Ian, the challenge is getting it to the women in the developing world who need it most.
Look, in Australia and the developed world, we have ways of controlling cervical cancer, and the vaccine is an add-on to that, and a very useful one. But in the developing world, where there are no ways of preventing cervical cancer at the moment, and where it's a common cancer, there we've really got to get programs out there which can show the vaccine can be used.
Today is the first day of the vaccine rollout. 1,000 girls will be inoculated over the next 3 weeks. But Ian has just 3 days to train up a local vaccination team and to help educate an island.
Father, help me. Father, help me. To be wise. And full of knowledge. For I ask.
It's an ambitious enterprise.
So we welcome you all to the school. Everybody, let's give a big hand to...
When you're rolling out a new vaccine, the first problem is that nobody knows what it's about. One of the big problems is to explain that it's not enough to give the vaccine before women get the cancer. You have to give the vaccine before they get exposed to the infection that causes the cancer. The vast majority of those infections are caught through sexual intercourse, and that means that most of the infections are caught in young adult life. And then there are the problems of ensuring that you get the girls to come back for the 3 times for the vaccine, and explaining that until you've had 3 vaccine shots, you're not protected.
Thank you. It's important for Mom. I came here for the health, for her health, for the future.
But there is a puzzling element to the cervical cancer story. Worldwide, around 80% of all women are infected with the human papillomaviruses, and yet only 2% go on to get cancer.
Most people who get infected with this virus have it for a couple of years. They don't know they've got it. It's a totally asymptomatic infection, and then the body clears it away itself. But for the unlucky 2%, the infection persists, and in persisting, it changes the cells that it infects.
When HPV infects a cell, it tampers with our body's critical tumour suppressor process. Usually, the body's repair team kicks in. If the cell can't be fixed, it's instructed to die. But evading the immune system is HPV's specialty. It can lie quietly under the radar, replicating.
It's a silent killer simply because you've got the virus infection, you don't know you have it, and all that time it's doing bad things.
No one knows why large numbers of women may be infected with the virus, but only a few go on to get cancer. There must be other factors at work.
Papillomavirus is necessary to get cervical cancer, but it's not sufficient to get cervical cancer. Other things determine whether you get the cancer once you've got the virus. So also with other cancers, the virus may not be sufficient to get the cancer, but it's contributing to the cancer. And that's really what we have to understand.
Today we know HPV is a common infection, and often carcinogenic. Several thousand kilometres away in Brisbane, Glenn Francis is asking, could it be involved in breast cancer?
Human papillomavirus is probably interesting because it has already been associated with a human cancer, and that's cervical cancer. Therefore, that makes obvious sense that we look for that in these patients' tumours, and it is a common virus, so it's a fairly obvious choice that we look for in the breast cancers. I actually don't know what the likelihood is. I'm open to the suggestion that it is possible it's there. It would be nice if we found something to link them together. I think it would answer a lot of questions.
Several international studies claim a link between HPV and breast cancer. Many are championed by Professor Emeritus James Lawson in Sydney.
We have found in Australian women, in their breast cancer in Australian women, about half carry the virus in the cancer itself. But there is almost no virus detectable in normal breast tissue. And we get normal breast tissue from women who've had cosmetic surgery. So it's really normal.
Studies show younger breast cancer patients have higher rates of HPV infection. James Lawson believes that the virus is spread sexually and that diet and hormones may accelerate viral replication.
We and others in 15 other countries have found HPV, human papillomavirus, in about half of all breast cancer. So it's very suspicious.
But so far, the evidence for HPV actually causing breast cancer is largely circumstantial.
It's not just enough to find the virus in the cell. You've actually got to show that it's doing something to the cell, and that if you take it away, that thing stops happening in the cell. And if you could show those two extra bits, then you might start to have a story. So I think it's very early days in this, and I personally would have to keep my mind open as to whether the viruses were involved or not. But I think on balance at the moment, the evidence is against it.
Well, the ultimate is to use Ian Fraser's vaccine. And then if it prevents breast cancer, of course, it's the ultimate proof.
But HPV is not the only virus suspected of causing breast cancer. There is another scuttling about, carried by mice. In the 1930s, scientists studying mice with breast cancer discovered the trigger was MMTV, the mouse mammary tumour virus. It's an insidious virus, inserting itself into healthy cells and corrupting DNA. It can lie dormant for long periods, erupting when exposed to hormones. So if this virus can cause breast cancer in mice, could it also cause breast cancer in humans? It would be welcome news if it did, because in mice, vaccination prevents breast tumours.
We are animals like the rest of the animal kingdom. We know that many cancers in animals are caused by viruses.
In New York, Professor James Holland argues there is an evolving story of a mouse virus.
If, in fact, human breast cancer were due to a virus, it would be a kissing cousin of the virus that causes breast cancer in mice, because nature is too stingy to invent two ways to do the same thing.
Working with viral oncologist Professor Beatrice Pogo, the team found MMTV in 38% of human breast cancers.
Subsequently, we've gone on using the techniques of amplification of the DNA, of the specific human DNA of breast cancer, and found the entire viral sequence, which is about 95% identical to the viral sequences in the mouse mammary tumor virus. And subsequently, we have pictures of it, and we can grow it. And in fact, we have used it to infect normal breast cells.
They did not find MMTV in normal breast tissue.
Based on that, we have to assume it's absent in the normal tissue present in the breast cancer. The women who had those sequences in their breast cancer acquired them. So we are opening up the possibility that breast cancer is potentially a disease that women could catch.
They argue women could catch the virus from a mouse.
Every woman has seen a mouse. Mice inhabit our food chain. Every civilized country recognizes there is a certain level of contamination of grain and other things which we eat. But we don't know. That's all speculation.
Another clue lies in geography. There is much more breast cancer in the Western world compared to Asia, but over time, Asian migrants acquire the same rates as locals. James Holland believes this may be due not just to changes in diet and hormone levels, as many experts think, but also to exposure to MMTV. Researchers in Canada have mapped the countries with the highest density of breast cancer. Then they mapped the global distribution of a common mouse, Mus domesticus, one of the main carriers of MMTV. There was a noticeable overlap.
In Western Europe and Western Europe colonies, including Australia, the mice came on the ships and potentially brought mouse mammary tumor virus, which could be an infectious factor for breast cancer. So we're working very hard on that because that's where, in fact, we think the answer lies. Now, all of those are very suggestive, but they're not proof. So we can't say that a virus causes human breast cancer yet, and that's what our research is about now.
Mice causing cancer. Some, like molecular biologist Professor David Vo, are not convinced.
The stories told by people like Holland convince a lot of people because they're nice and simple and are appealing. And people have a need and want to believe in a simple story. But the science is more complicated than that. They're claiming to have discovered something that many other people have looked for and not found, and yet all of their evidence is incredibly weak and is much more easily explained in terms of contamination. I've read their papers and I've seen their evidence. Yeah, I'm absolutely convinced this data is wrong and should not be taken seriously.
Yet the debate has got the experts talking.
You know, when you put it all together, you can't say it's rubbish. There's nothing going on there. This just can't be true. And as a scientist, when I see that, I see work that needs to be done, not arguments that need to be stopped.
The story gets very complicated because it begins to look as if there are a number of viruses involved in breast cancer. This accounts for the difference in different breast cancers. They look different, they act differently. There is a rational explanation. It is the whole variety of viruses.
If correct, this would require a complete rethink of breast cancer.
Paradigm shifts don't occur in the labs where you're just doing the same as everybody else is doing. They occur because somebody thinks outside the box and turns out to be right. On the other hand, you have to remember that for every one person who thinks outside the box and gets it right, there'll be 100 who think outside the box and it turns out not to be.
So we're not claiming that it's the cause or even a cause yet. What we are claiming is this is a wholly legitimate area of research, and we think this would be of great importance for women in the world.
I want them to find what's causing breast cancer. I want them to find it today. I want them to find it yesterday. I want them to be able to say, this is what it is, here's a needle, no one else in this world is ever going to have to go through breast cancer again. That's what I would like to see.
Even with a needle, stopping cancer is a challenge. It's the second day of the vaccine rollout in Vanuatu, and Ian Fraser's team is travelling to a remote school on the far side of the main island.
Many of the places we need to vaccinate are a very long way away from Port Vila, where the medical staff who can deliver the vaccine actually are. And therefore, getting information out there becomes a challenge, not only for us, but also for the Vanuatu nursing staff.
But there's been a major setback. Fear of the unknown. The community are not sure they want their girls vaccinated.
So through lo screening with them stick medicine na pa imi sabe seven life plo one mama. So emi important to mas plo yumi protect them all future mama plo yumi. Cervical cancer pe stick no sa encourage mo age mo one age lo future lo kana.
I mean nothing to do with the age. Every time we let talk to school, we will encourage them to want to talk to them school beginning. We will tell them say life lo ivula, hemi very important. So we will tell them lo mama, stick medicine hemi help block them no more cervical cancer.
To date, over 20 million women have been vaccinated with this vaccine worldwide, and the safety has proven to be better than most other vaccines. A few people get an allergic reaction to the vaccine, less than 1 in a million. And if the vaccine is safe and it looks like it's working, why would you not have it?
But the community remains unsure.
But anyway, thank you so much.
The vaccination programme will not proceed today.
People should ask questions about anything, particularly when 3 groups of people turn up in rented cars, lots of money from overseas, and start saying, this is good for you. You know, you should really ask, why us, why here, why now? In any country where you're going in with something new, I think that's the right questions that the community should be asking.
Around the world, over 10 million cases of cancer are diagnosed each year. And according to the World Health Organization, that number is set to increase to more than 15 million per year by 2030. So, what makes us so vulnerable to cancer? Part of the answer lies in our DNA.
We've been engineered by natural selection, and it's full of compromises and fallibilities and trade-offs So we're imperfectly designed, I'm afraid. You have millions and millions of cell divisions every day. Mistakes get made. And interestingly, if it was engineered so that mistakes never happened, we wouldn't have evolution, so we wouldn't exist. So a certain level of error is permitted.
So, we are programmed for fallibility. Our ability to juggle our DNA is a strength. But add certain triggers, specific DNA hits, and the error rate can increase. Understanding how it works can help us all stack the odds.
This slot machine is a wonderful metaphor for how cancer actually develops in our bodies. We need a number of mutations over a number of years to get cancer. We don't know the right number, anywhere between 3 and 12, but like the slot machine, let's just say we need 4 mutations. And every pull of this handle is one of the risk factors. So let's have a go at this game. This is your background genetics, who your parents happen to be, which of course is chance, you can't choose them. One more roll of the dice. Okay, there's an ace. That's a mutation, that's bad luck. The next handle I'm going to pull, let's say it's lifestyle. It could be your diet, the amount of exercise you take, and so on. The point about this game of chance is the longer you play it and the more times you pull the handle, the more likely it is you'll score an ace or get a mutation. And there's a second ace.
A critical variable is infection with a cancer-causing virus.
There's a virus infection. So that's 3 aces. Things are getting pretty serious. We're on the road to getting cancer here, but it's still not sufficient.
And sometimes a sheer random mutation can tip the odds.
There's the 4th ace. 4 in a row, a full set of aces, a full mutation set. It's cancer. It's a game of chance.
A vivid example of the multiple hits required to cause cancer comes from Mel's own specialty, childhood leukemia. But in this case, only 2 hits seem to be required.
This is Joe. He lives with his mum, dad, sister Hayley and baby brother Alex. He has a dog named Scruffy, a hamster named Harry and 2 goldfish called Bubbles and Beryl. Joe became ill during his first year at school. That's like you, Tom, isn't it? And this is the story of what happened to him.
5 months ago, 5-year-old Thomas Kaup was diagnosed with acute lymphoblastic leukemia.
Joe had to have lots of tests. Some of them hurt a bit. But Mum or Dad were always there to give him a cuddle.
His identical twin brother Daniel is healthy.
The nurses were very kind.
Thomas had been tired and unwell. His doctors called for a battery of tests.
It was 5 o'clock that evening, wasn't it? That Mary Morgan, our consultant, Mary Morgan,
inside the room, we were pacing around, weren't we, waiting for the results?
Called us into her room with the nurse, the obligatory nurse and the tissues. So you thought, right, this isn't going too well, was it? And then we were...
Well, by this time, we were pretty much, fearing the worst.
The hospital doctor saw Joe, Mum and Dad, and explained that Joe had leukemia.
When she told us, it wasn't a massive shock initially, was it? Because we'd all sort of...
But it was still the worst thing in the world.
Yeah.
Why do you like your scenes?
Thomas and Daniel are identical twins. They have the same genes and immune systems.
Good.
Why has one got cancer and the other not? Mel's team discovered that pre-leukemic cells developed in one of the twins during pregnancy and spread to the other while in the womb. But this genetic mutation, or first hit, was not enough to cause cancer.
Medicine.
Your medicine?
Yeah.
Further tests revealed that Thomas's blood stem cells carried a second defect that switched the cells from a pre-leukemic state into full-blown leukemia. But what was the second DNA hit that flicked the switch?
Well, there's a lot of debate about this, and it's an unresolved major question, but we're reasonably confident the second hit is precipitated by, I like the word trigger, triggered by infection. We don't think it's a specific infection. It's one of a number of bacterial or viral infections which we think can trigger an abnormal bone marrow response and flip the pre-malignant cells over to acquire the secondary hits for full leukemia.
It seems the timing of the infection is critical. 3 major international studies suggest the immune system of a child is primed and protected by their exposure to infections in the first year of life.
What we found was a quite dramatic link with exposure. The more exposure you had to other children, the less lymphoblastic leukemia. So that was a very pleasing result, actually. So if contact with other children is protective, I can't imagine anything else other than infection that's doing that.
Knowing that leukemia is caused by at least 2 DNA hits has real benefits. Daniel, the healthy twin, has had the first genetic mutation in the womb. Now the doctors can be ready if there's a second hit.
We feel better knowing that there are people testing him, because they will pick it if he does, God forbid he does, but if he does get it, it will be picked up very quickly and then they can start the treatment very quickly.
You know, when I lost my hair, and you're so self-conscious about the hair for a female, I think. And I got the hairdresser to come up. They had a hairdresser at the hospital and I just said, cut it off. And she cut it. Sorry. And I said, cut it short so, you know, it's not going to be bad. And she cut it and she said, you've got bald patches. So I sat there with the cape around me and I just said, shave it off. So, and I came home and my eldest said to me, Mum, I can't see you without any hair. Can you just... And he'd just start crying. And that distressed me no end, that he couldn't see me. So I had to either wear a beanie or cover my head the whole time because it would freak him out. It freaked me out. I was so stupid that I'd have a shower and put a shower cap on. That's how stupid the whole thing got, which was so bizarre. Who would do that?
The first one is A10278.
In Brisbane, Glenn Francis has tested the tumours of the women in the ABC cluster.
10316. Yeah,
His team is now analysing the results.
And we'll do a little bit more work to... Certainly we found some interesting data, at least in the subtype of the tumours. Probably a little bit different to what we sort of expected. Well, that bears out.
There's nothing concrete,
As you said, that's sort of...
but there are hints. In Perth, Western Australia, tantalising hints were the trademark of another successful medical investigation. For decades, experts believed that stomach cancer was caused by peptic ulcers and that ulcers were caused by stress.
Who was the original person that thought that ulcers were caused by stress? It's impossible to find that person. It's somebody's mother back in the dark ages, that's all I can say. So for us, we didn't think it was dogma, but of course everybody else did think it was dogma.
Dogma couldn't shake the conviction of Australian scientist Barry Marshall that in fact bacteria were the real trigger.
So Helicobacter means a spiral or twisty germ, and over many years can sometimes cause stomach cancer, so that's why it's kind of famous.
Your discovery has meant that this disabling condition now can be permanently cured by antibiotics to the benefit of millions of patients.
Tenacity won Barry Marshall and his collaborator Dr. Robin Warren a Nobel Prize. It took them 20 years to prove their case. Just like cervical cancer, many people are infected, but only a small number go on to get cancer. And the cancer occurs several decades after infection.
If you have not picked up on the essential factor that they all have in common, you'll never really sort it all out, and you'll be chasing red herrings for the rest of your life.
And, once again, these scientists were challenging the accepted wisdom of the time.
A lot of people today forget that they may have scoffed at the idea that this spiral organism, Helicobacter pylori, causes peptic ulcers. And similarly, I think people forget that they may have scoffed at the idea that cervical cancer is actually caused by a virus.
So if infections can trigger cervical cancer and stomach cancer and possibly childhood leukemia, should we be worried? Could any of us catch cancer? The answer is yes and no. The atomic bomb remains the most potent man-made DNA hit ever inflicted on human beings. But even this dark cloud has a silver lining. In a surprising twist, studies show that although survivors had DNA damage, most did not go on to get cancer. Even this mighty DNA hit on its own wasn't always enough.
The legacy was nothing like as high as you might have anticipated given the level of damage. So it tells us there's remarkable repair capacity, and simply damaging DNA and causing mutations in one shot is not sufficient. And it's a much more complex process than you might imagine. The challenge here is accommodating complexity. If you want to know what really is happening in cancer, you cannot avoid complexity. Multiple things have to come together to give you cancer.
So you can't catch cancer like you catch a cold. At least, not if you're human. There are only two cancers that are known to be genuinely contagious. The first is a rare cancer found in dogs. The second in this Australian marsupial, the Tasmanian devil. In both cases, it's the actual cancer itself that is the infectious agent. It has evolved to evade the animal's immune system.
Fortunately, human cancers don't behave like that, with very, very rare special exceptions. But generally speaking, it's very important to take on board that cancer is not a transmissible disease.
We don't catch cancer from someone else because our body's defense mechanisms protect us. But we can and do catch the infections that can trigger cancers. Ian Fraser's work in Vanuatu is almost done. After today, the local team must carry on the work independently. From deciphering its mysteries under the microscope to delivering a vaccine on the front line, eradicating a major disease takes dedication, money, and, like cancer itself, lots of time.
Realistically, since we get these infections that cause cervical cancer when we're young and first sexually active, and cancers take on average 20 years to occur, it will be 20 years before we start to see the rate of cervical cancer falling as a result of a vaccine programme.
HPV is not just an issue for girls. Given males also carry and spread the virus, vaccinating boys is an option in the future.
This morning, the Vanuatu team have got through immunising about 80 kids in about 4 hours, which is really magic, and that really is what we've been trying to achieve. They've done it all themselves. I'm delighted it's all working. I think our job's done here.
So we just wanted to give a brief update on where we are with the ABC cluster.
After a year, Glenn Francis and his Brisbane team have accumulated an invaluable resource. Raw data from a rare cancer cluster.
X years ago.
But there is no evidence as yet of a virus. This doesn't mean they're not involved, only that they haven't found them.
Finding something present.
I'm probably actually still excited because there's a suggestion there's something there. I don't think we've gone into the HPV information in quite enough detail. I think there's the possibility we can look at it in different methods, different ways. I think this is good, but we're still not there yet.
Perhaps there will be no virus, but a significant cancer cluster such as this one is an obvious place to keep looking.
Ultimately, you can't ignore clusters because one day there will be something important.
So just out of interest, was from your perspective, was this a worthwhile exercise?
Oh, yes. The information we have still adds to our knowledge. I think it's critically important that we do this. A negative study doesn't mean that it's a bad study. It means that we haven't found the link. Our technology can't identify it at this point in time, so we don't know, but we'll keep looking.
And it's only been a year. For virus hunters, that's nothing.
Persistent agents require persistent researchers. So in a way, it's in every case, it's quite laborious. It takes time, and it takes indeed persistence.
% of all human cancer cells like these are triggered by infection. They have the power to unravel lives. Now, many more cancers are under scrutiny by a new generation of virus hunter. New vaccines are powerful incentives.
I think we have to extend our thoughts to every cancer type to see whether a virus might be at the bottom of it. Bearing in mind that we recognise that all cancers are caused by multiple agents. It's not just the virus infection that produces cervical cancer, it's part of the story. So the same may apply for other cancers as well.
As our understanding of cancer deepens, the complex interplay of genetics, lifestyle, and infections is being revealed.
We're in the midst of a quiet revolution. That revolution involves recognizing that infectious agents are playing critical roles in instigating cancer. Once we know an infectious agent's causing a disease, there's usually something we can do to prevent it. We can make a vaccine, we can have an anti-infective drug, like an antibiotic, or we can improve hygiene and keep people from getting infected. One of those three ways almost always gives us major advances. So it's scary, but I think it's actually very good news.
Three days after Ian Fraser's departure, Mari died. The vaccine came decades too late for her. But these young girls may never have to worry about catching cervical cancer. They are stopping the virus that starts the cancer. So finding a hidden trigger, such as a virus, is no reason to panic. It's a reason to celebrate.